Okay, so just to show a demo of what we'll be building today is this is a dictionary app that we're building. So it looks like this. We have a search bar here, and here we can type a word that we want to search for. For example, let's say mouse, for example. When we search for it, there will be an API call and we will get the result of. This is the meaning that it's a noun, the definition. That's a small rodent that typically has a pointed, and then this is the computer mouse. So this is a dictionary app that we'll be building today, and this data we'll get from our API. So like before, like let me send you this app in Telegram itself, so you can play with it a little bit. All of you have joined the Telegram group, right? Just write in the chat box once. Okay. No. Okay. I think can you share the link for the Telegram group here? Okay.
I'll be sharing it in a second. You can continue.
Yeah, sure. Just a second. So everyone just check out the Telegram group and see if you can download the APK or not. Just open it by yourself if you're able to install it or not. And then just write in the chat box if you can do it or not. Maybe I can find the link here for the Telegram group.
I have shared it.
Okay, sure. Thanks. Great. So I'm sure you can join the Telegram group. And rest everyone try to install the app and just inform once if it's working or not. I have some problems in interface preparation. Like, what do you mean by interface? Like in the app? Okay, I guess the app is working. Arjun can answer your question, Gaurav. Hopefully, it's working. Great. So now let's start building the app. I guess I can close the mirroring. So let's create a new project here with an empty activity. And you can follow along as well. Like if you have Android Studio installed and open, you can try it. Let's name it a dictionary. And this is the folder where I want to save it. Keep the minimum API to 21. We're using Kotlin language. This is the package name. Everything seems okay. Let's build it. So the project is building right now. It will take a minute or so. Is the text visible to everyone, like the font and the brightness of?
It's visible.
Okay, nice. So let's wait for the project to build. Now while it builds, let's take a look at the API that we are going to use. I think I will drop a link to the API that we'll be using. This is the API. It's api.dictionary, api.dev, and there's this endpoint called API v2 entry/en. So how this API works is, at the end, you type in a word and it will like return the meaning of that word. So here I type hello. Let's try the mouse one example again. This is the response it gives you. Now this response, you can see it is JSON format, but it doesn't look that great. It's not readable. So you can just for any JSON beautifier, search for beautify JSON and click on any of the links. Like let's go for the first one. And it will help us better visualize the JSON that was returned. Let's copy it and paste in a JSON beautify. Let's click on the beautify button. So this is the response that we get. Let's try to analyze what is this response. So it starts with this square bracket. I hope you can see that. This is square bracket. It means it's a JSON array. Inside the JSON array, we have a JSON object. Now JSON array can contain multiple objects. In this case, we have just one, and we only care about the first one. Okay, now what's inside the object? It starts with a word called mouse. This is the word that we searched for. And then we have the phonetic word, like how is pronunciation. We do not care about this information because it's the audio. Like if you try to run it in your browser, it's just the pronunciation of that word. Like if I try to copy paste it, it's just a music file, like audio file.
Mouse.
I'm not sure if you heard it or not, but it's just pronounced mouse. We do not care about this information. The next one is the origin of the word. Like for dictionary, yeah, we don't care about the origin as well. Like here it informs well, what's the origin of this word. Now this is the part in which we are interested in, the meanings part. If you can see, meanings again is a JSON array. It has multiple meanings. What is inside each meaning? This one meaning. It's a part of a speech noun. And then in the next, we have verb as a part of speech. So mouse is a noun as well as a verb. Now in the noun, we have some definitions. These are multiple definitions, like the multiple meanings of a mouse as a noun. The first definition is a small rodent that typically has a pointed snout, relatively large ears and eyes and a long tail. It refers to the rat. And the second definition refers to a computer mouse. And you can see the second definition has an example as well. Copy the file with the click of a mouse. We have another definition and an example. And in some definitions for the verb part. Mouse is a verb. So we have one definition of mouse as a verb, and then an example. And we don't care about synonyms and antonyms right now. And then we have another definition and another example here. So this is the response format that we get from the API. Like I would ask you to like.
Can you explain a bit more about what is an API?
Okay, so API is, I think it's application interface. So it's something in the cloud, application programming interface. So it's something in the cloud where we can send requests and it will process that request and return some response. You can send some request, it will process the request, it will give the output. Now, like anything that you use, for example, you write a chat app, so you send the message, so it sends to an API, it makes a request to the API that, okay, I want to save this message in the database. So that's saved. Then it sends a response that, okay, it was successfully saved. Or maybe there can be a failure, so it has failed. So API is just a way in the remote. So you can trigger it, send request to it, and it will give you the response. And this thing called REST API is again like APIs can be many types. Like in Android, whatever you use, these are also APIs. So REST API is what lives in the internet. So you can trigger that, send a request to it, and it will give you the response. Like, have you guys tried opening this API? Like, I would encourage you to use this API and just type in some words and get their meanings. Just see if the format. Like for example, if I try to send another request for like instead of mouse, let me type computer. This is another response that I get. If I try to beautify it, this is what I will get. So it's a computer, and the definition is an electronic device for storing and processing data. This is the definition that we are getting. So while working with internet requests, the first most important thing is to understand the format in which the API returns the data and the format in which it requires the request. In which format do we need to send the request, and what is the format of the response given by the API? So have you guys like tried like sending some words, typing some words? Just type some random words, maybe apple, banana, car, cat. It will give you the response. And tell me in the chat, I will wait for some of you. The API is showing this. So just current you have typed some word which does not exist in the dictionary of the API. So what word have you typed? It must be something that meaning is not found in the API dictionary. So if I type some garbage value here like AABB, CC something. So in that case, it gives this response. So no definition found. So if there's a word that does not exist in the dictionary of the API, it will send this response. It means that there's no word. Okay, just open it. Okay, so the word that Arjun typed in the is just an angle brackets in the word. So you are supposed to replace it with your own word. The API link that Arjun gave has a angle brackets and word inside it. So replace that with a proper word and you will get it. Okay, so the most important part is this format because we need to parse the data in this format. Now let's start building the app. So our project has built. The first step is to add some dependencies here. Now to make API calls, we'll be using a library known as Retrofit. Like if you Google for the Retrofit library, you'll find the entire documentation. This is the website of Retrofit, and here you can get the basic demonstration of how to use this API. So after the session, if you have any doubts on how to use it, you can refer to this documentation, and then you can grab the dependencies. So I'll just add the dependencies here. So these are the dependencies that we need. The first one is the retrofit dependency. This is required to make the network call, the API call, and get a response. Now the response that we get, that's in a JSON format. What we want is to convert that JSON into a Kotlin class that we can use in our program. So this is the converter that's used to convert that JSON response into a Kotlin class that we will provide to it. Then we have a ViewModel dependency. So if you attended the last session, we had introduced to the ViewModel concept. This is the place where we use to put our business logic and all the data so it's not lost on, let's say, device rotation or theme change. And the fourth dependency is kind of a helper dependency, which will be used to use some functions of the activity. So you can use these four. And one more thing that we need is we need to enable view binding here. Probably you'll be familiar with view binding because we've been using in the past 2 sessions to build features and set view binding to true. After doing this, you need to click on sync now. All the dependencies are fetched from the internet. So it will just import all the dependencies, and let's wait for a minute or two. Okay, so it's done. Great. Okay. Now let's start with building the UI first of all. So let me just again take the app UI. Give me a second. This is what we are trying to build. So let me take a screenshot of it to refer later. This is the UI that we're trying to build. So in the top, we have something where we can type text. This is an edit text. And then we have a button here. It's actually an image view that we'll be using as a button. And then we have this whole text for keeping the definition part. So because UI is not the main focus of the current session, and you should know how to build basic UI from the past sessions, I'll be just copy pasting the code. Now let's understand what is all here. So this is the UI that we get from this code. Maybe Arjun can share the code in the chat, the GitHub link. So we have a constraint layout here. This is the top level layout that we use to put elements in. This is the basic stuff. This is match parent. So this layout will cover the entire screen, so the entire width and the entire height. And this is a gray color. So you can see from here, this is a light gray color. So this is for the background that we get here. It's not white, it's a light gray color. This color code corresponds to light gray color. After that, we have a material card view. So this is this card. We're using card views so that to get these rounded corners, because we don't get them in normal views. We have a card view, and the constraints are the end is constrained to the start of search button. We have a search button here, and the end is constrained to the start of this search button. And I don't have an image for the search. So we have done this in the previous session as well. Just click on drawable, go to new, go to vector asset, and here we can look for the icon for that search button. It will load all the icons, and then we can pick the search icon, this one. Click OK. Let's rename it to IC search. Click next. Now we have the icon. So you can see this icon here. Let's minimize it. So this card view is constrained. The end is constrained to the start of this view. The top is constrained to the top of parent, and the start is also constrained to the start of parent. So this is how we position the card here. The card has a margin of 16 dp to give this spacing here, so it does not stick to the boundary. And the height is wrap content, so as high as content requires to be. And the width is 0 dp means it should expand to match the constraints that we have given it. Inside the card, we have an edit text. This is where we will type our search query. It has a width of match parent, which occupy the whole space, a wrap content height, a background of null to remove the underline that we get in edit text. Now this is the hint that you are seeing here, search. There's a horizontal padding and the vertical padding to just push the text to somewhat in the middle and leave this space around white. Then we have this image view, the search icon. We have given an ID. The width and height are set to wrap content, so that this image view should be as big as the image itself. It should be a little bit margin from the end. This should be a small margin between this image and the end of it. And a padding of 4 dp so that we have a more space to click on it. And this is the image that we want to put in the image view. So IC search. So this is the image that we fetched from. I just picked from the vector asset. Again, the standard constraints. The bottom is to the bottom of this card. The top is constrained to the top of this card. And the end is constrained to the end of parent. After that, we have a scroll view. So sometimes what happens that the content that we have, it exceeds the height of the device. So what we want is that we should be able to scroll this content. So to be able to scroll this content, we put a scroll view here. Again, the constraints are usual, like to the bottom of this card, and it will extend till the bottom of the parent. In the small margin, let's push it from the boundary. Inside the scroll view, we have this card, this white colored card. Inside this card, we'll put our definition. So it has a white background. This is a corner radius. So you see this small corner here, the curved part. This is responsible. This attribute is responsible for the curved part. Card corner radius. We have set it to 12 dp. You can play with it to give more. Like let's say if I set it to 24. Well, this is more curved, like almost a semicircle kind of thing. So let's keep it to 12 here. So we have a small curvature at the top left, like all the 4 corners. And this is the main text view that where we will put the definition. So occupy as much width you can. The height should be as high as the content. A small padding. We want a black text color for the text and a size of 16 sp. And this is a sample text, so definition hello to see how it looks like. So this is for the UI part. We don't have a lot of elements here, just a few 4 or 5 elements. A card and an edit text inside it, a button to search, a scroll view. Inside we have a card and a text view. So pretty simple UI. Now, does anyone have any question related to the UI that I built? Like, does it seem okay? Like, if you have not attended the previous session, you will find it a little hard to understand. But like, if you just go through it in the YouTube or somewhere, you can go to it later. The UI is not the main focus. This is how we place the elements. So any doubts here in the UI part? Okay, I guess there's no doubt. Okay, now let's move ahead to the main part, the networking part. So now we want to get data, and then we want to do our own class. So let's create a new package here. Let's call the data package. It's optional. You might want to create, or you can just skip it also. Let's create a new Kotlin class here, and let's name it response model. You can name it anything you want. And this will be a data class. But we'll create a data class here, and this is the model that will.
Can you take few questions from the chat?
Okay, then nope, it was clear. How to link a Java code to a Kotlin code? How do you search for? Okay, how do you link a Java code to a Kotlin code? So Kotlin is 100% interoperable with Java. I'd like to give a small example. Let's say I create a small Java class here. Like, it's not part of the session, but let's say just you have asked. Let me show you. So this is a class, and let me create a function here. So void main. So you can see this is a Java class, and this main activity is a Kotlin class, main.kt. You can just normally create an object for that hello world class. Let it autocomplete. Hello world. And you can call that main function on that. Let me make it public. So this is the usual way. It's a Java class. You have some Java code inside it, and in the Kotlin file, you can call it just as usual as you will be doing with Kotlin classes. So I create an object of that hello world class, and I call the main function. So if I have some print statement inside this function, main function, it will be printed in the console. Like for the Android part, you will not need to link Java code with Kotlin because we're working with entire Kotlin. And then how do you search for the search icon? Okay. So all the icons that we'll be using and all the images that we use, they are placed in the drawable folder. So resources and then drawable. So right click on the drawable folder, go to new, and then go to this vector asset. Now once you go to this vector asset, you have two options. Either you can choose from predefined icons, or you can put your own SVG icon here. So I went for the predefined one. So just click on this clip art button, and it will load a bunch of icons for you. There are a ton of them. So like all the ones that you might need. So there's a icon for back button, for up button, and for some networking, lock, message. Like all the icons that you might commonly require, they're all of them present here. Just search for them. I search for the search icon. So SER. This was the search icon. Just click on OK. You can keep the defaults, they don't matter much. And just click on next and then finish. And you will get this icon here. All that you need. It will get in .xml file. So it's an XML vector icon, not a normal PNG file. This is more efficient than a PNG file. It occupies less space actually. Does that help? Yes. Yes, okay. Nice. So you can remove this hello world class. Delete the calling code as well. Now we need to create a response model. So the response model will be based on what format of data do we get in. So we have this. Let me take a better example here. The mouse one was better. So we search for mouse, copy it, it's in Beautify. This is the format. So first we have a world. We don't care for this world, and we don't care for these also. We can ignore these. Then we have a meaning. So meaning is a JSON array. So this is what we want to take. So we'll create a meaning variable, meanings, and this will be a list of some object. This is again a custom object. we'll have to create this object as well. With the class corresponding to that particular JSON object, and let's just name it meaning. What is inside meaning? We have a part of speech. Okay, fine. It's a string. So let's take that, and it's a string. And what else do we have? We have definitions. Okay, we want that. Definitions. And definitions is again a JSON array. You can identify it using this square bracket. So square brackets means it's an array. An array of what? This is again a new object. So again, we need to create a new class. And let's just name it definition because it's definition. Definition. Now what's inside the definition? We have a definition variable here, which is actually a string. So let's put that here. Where definition. It's actually a string. Fine. What else? So we don't care for the synonym antonym, but sometimes we have this example here. Sometimes it is there, sometimes it's not. We want to get this example as we want to display this example in our UI. So you can see here, like when we have this example, we append it at the end of the string, and when we don't have, we just skip it. So this example should be optional. So sometimes it is there, sometimes it's not. We'll create an example. This is a string, but sometimes it is not present. So what you can do is you can string mark this as a nullable property, give a default value of null. So if we do not have an example in that definition, it will be marked as null. So for this definition, we have an example set to null, and for these remaining ones, we have a proper string example. Like they all have an example here. And now in our meaning, we have a list of this definition that we just created. The response model contains a list of these meanings. Now make sure to write, make sure not to make any typos here, because these will be mapped to these names, these meanings. So if you rename it to something else, it will not work. Just make sure you don't make any typos here. I hope I haven't made any definition. Yeah, looks good. So this is part one. We have prepared a model in which we want to parse this response. This was step one. The next step is to prepare retrofit for it. Now let's start let's create a new API called definition API. And this API is actually an interface. Retrofit accepts an interface. Now inside this interface, we need to specify what are the different API endpoints that we need to access. So for this case, if you remember, like this is the main website, api.dictionary, api.dev, and this is the endpoint that we are sending a request to. So like api/v2/entries/en, I guess en for English. This is the path, and we also have this world inside this path. This is the path where we want to send the request. We'll create a function here. Let's call it getMeaning. And this will accept a word, which is string. So the word for which we want to get the meaning, or you can also name it get definition, like whatever you like. Let's call it get definition. And then what should this function return? Like if you take a look at the response, this is a meaning, but it is returning a list of meaning because it starts with the array. So it will return a list of the meaning class that we made. Now there are several types of requests you might have heard about. There are get requests, post, put, and others as well, like delete. All these requests are used for special purposes. For example, get request is used to get some data from the API. A post request is used to send some data to the API. Delete is used to ask for the API to delete something, and so on. Like in our case, we want to get data. So let's write an annotation here. This is a get annotation. And in which, what is the endpoint that we, like from where we want to get this data? So this is the endpoint, the API/v2/entries. This is the endpoint we want to get the data, but we have to put the world here. We don't always want to search for the mouse. We want to give our own world. So let's replace it. This syntax is used to indicate that we want to fill this value with our own variable. Just put in curly braces, and retrofit will understand that this value it has to take from the arguments. You need to match this argument with this variable here. For that, you need to add an annotation. Use the path one. So path from retrofit to .http. Import it. Just mention that we need to map this variable to this argument. So if you use world save, it will be world save. You have to keep these two same. So this value will be taken from this variable. And since you are making a network request, so a network request takes some time to execute. We'll be leveraging Kotlin feature. This is the coroutines here. This is a suspend function. It will mark that this function might not return immediately. What does that mean? This function might take some time to return because API requests do not happen instantaneously. So we send a request, it goes to the server processes it, and then returns the response, and then we get the response. So it takes some time. So we will mark as suspend function, which means that we are going to leverage the coroutines power here. So this is it for the API part. The next thing that we need to do is we need to make an API service that we'll be using. So create a variable, name it whatever you want. It will be a type definition API. And let's use another Kotlin feature here, which is lazy. So what does lazy mean? Normally you assign variables like this. Val a is equals to 5, maybe var x is equals to some hello. What lazy does is that these values are assigned at compile time, like immediately. But the value that we give here, it will not be assigned immediately. This will only be assigned lazily. If the first time we access this variable, at that moment, this block will be executed and the value for this API service will be calculated. Like if you write this way, like whenever the control reaches this point, it assigns 5 to A. But if you write it like this, by lazy 5, this 5 is not assigned immediately. It will only be assigned when you first access it. So this is done to avoid some heavy computations. For example, in some cases, if the computation is pretty expensive and we want to avoid it if possible, so we can put it inside a lazy block. But if we do not call this function, we never access it, we should never need to initialize it. This is just an optimization that you can do in Kotlin. And what is the value of it? So step one is to get an object for retrofit. How do we get that? We call retrofit, and then we follow the builder pattern here. Builder. Now the first step is to add a base URL here. What is the base URL? So the main URL that we want to send the request to. So it's https api.dictionaryapi.dev. Let's use that one. I'll just copy it here and just paste it. This is the base URL that we want to trigger, send a request to. And then we need a converter factory. Remember the Moshi dependency that we used in the beginning? So this one. This was used to convert the JSON response to our response model. So we will add a converter factory here. Moshi dot builder. Working. Moshi converter factory dot create. We attach a converter factory to retrofit so that whatever response you get that will be in JSON, use this converter factory to convert that response to our data class, the Kotlin data class. So it is used to convert that JSON to our Kotlin class, and then we build this instance. And using this retrofit object, we can create our own API service. Create. We want to create an instance of this definition API, an implementation of this interface. Definition API, like class.java. So this is it for the retrofit part. Like we define a definition API where we put all the functions that we want to execute, all the different endpoints we want to send the request, the type of request, the endpoint where we want to send the request, and the function that we'll be using to send the request. It is a suspend function, means we are using coroutines here because the function might not return immediately. This is the world that we want to search for, and we want to map this world to this parameter in the path, and it will return a list of meaning. and then we use Retrofit to build the API service and implementation of this interface. To get into the Retrofit, add a base URL where you want to send the request, and then add the converter factory. Which factory do you want to use to convert this JSON response to your Kotlin class? So this is all the syntax that we use to build Retrofit. So that was step 2. Any doubts here? Like anything you didn't understand this part? And then we'll move ahead. What about exception handling? So we'll handle the exceptions when we'll call this function. So yes, you're right. There might be some exceptions that the request didn't succeed or something like that. So we'll handle when we call this function. Right now we are just mentioning that we have this function, that we want to use this function. And we'll handle the errors when we actually call this function. We're not calling it anywhere right now. Just defined it. So no, like it's in gray color. It's not being called anywhere. We'll handle all the exceptions when we call this function. Great. Okay, so let's move ahead. Now we have our activity here, and let's do some UI stuffs. What we want is that whenever we click on this search icon, we want to send a request. So let's get the bindings first. So if you this we taught in the previous session, the last 2 sessions. So the XML name is activity underscore main. So the binding name will be activity main binding. This is in camel case, snake case, and the binding name is in Pascal case. So all the words stick together with no spaces, and the first letter of each word is capitalized. That's the Pascal case. And we'll inflate it using layout inflator. In the set content view, we can use this binding dot root. Dot root refers to the root view. Now we have the binding here. What we want is binding dot search button. So this is an image view. Whenever we click on this button, so what we need to do is we need to set an on click listener. So whenever we click on this image, this function will get triggered. So let's grab the text that you typed as the query. Val world to search. Let's get the edit text first. So this is the search text. Get the text out of it and convert it to a string. It's quite possible the world is empty. User didn't type anything and just press the enter button, the search button. So we want to ignore it, and only if the word is not blank. Not blank means it is not empty. It also contains some other character other than just a space. So if it contains only spaces, we don't want to consider it. We want to work only with like non-empty characters or words. Now here we want to send the request, but like a good practice is not to put the network call in the main activity itself, because it has a different life cycle. Whenever you rotate your device or you change the theme or the font size of your app, there are a lot of cases where the activity is destroyed. So we do not want to put any network call or any data related code inside this activity. For that, what we will do is we'll create a new class. It's via view model. So let's name it a definition view model. You can name it whatever you want. This is a view model class we have, and this will extend the default view model class that we get. Now to get this view model in the activity, what we can do is we can say private variable named view model, not this view model, and we can get it using this delegate function called view models. So now this definition view model. There we have this view model instance that we wanted, and this function is actually present inside this dependency. This dependency was so that we can use this function here, this ViewModel function. If you go inside it, it's inside of activity.viewModels. It's an extension function. We don't care what it is. Just use the dependency here. So now we have our ViewModel, not inside the data package. So yeah. Okay, so there's another thing that we taught in the previous session about live data. So what is a live data? A live data is an observable data holder. So we have, normally let's say we have this thing. So val a is equals to 5, and there's some function xyz, which is reading this value. So print a. What happens is whenever we change this value, this function will never know that the value changed, because by default it doesn't happen. So if we change its value, let's make it a var. So if we change its value, the consumers of this variable will never know that the value changed. So to fix that, sometimes we want like observers to get triggered when we change a variable, change some data. So for that purpose, Android provides us with a class called live data. So let's create a live data here. Let's name it definition live data. It will store the result that we want to show in this thing, the text. And it's a mutable live data. It's mutable so that we can change its value. Otherwise, we will not be able to. And let's set the default value to 1, so that when you first open the app, this is all empty. Okay. And let's complete the main activity part here. Okay, we need one more function here. So in the model, we'll create a function to get definition. We will take a word here. It will be a string value, API, and then so if the word is not blank, function of ViewModel. So ViewModel dot get definition and pass in this world. We have sent this world. Inside this, we'll write the code that will call the API, get the response, and then use that response to update the value of this live data. So when this live data gets updated, we want to update the text in our screen. What we want is we want to listen to changes to that live data, or you can say observe the changes. So this is the class that wants to observe it. And whenever you will change the value of that live data, this function will get triggered. So the code inside it will run again when you get a new value. Now, when we have a new value, what we want to do? We want to update the definition text. Definition text is this text, the XML. Dot text is equals to it. Is that variable the value of this live data? And let's do one more thing. That we have a white colored definition card here. Let's make the card invisible if there is no text in it, so that initially we don't have this white card in your screen. So it is visible. This is another property inside the view, and set to it dot is not empty. What this means is, if the result, if the value of this live data is empty, this value will be false, and visible will be false, which means it will not be visible if this string is empty. And if it is not empty, this card will be visible. That's what we want. That's it for the main activity part. That's all we had to do. Now the only remaining part is in this view model. So we need to make the network request, we need to get the response, and then we need to show it. Let me open the emulator till then that it opens up.
I think instead of changing visibility, you can like just change the text that a word is found or like something like that.
Like initially it will be empty, right? So I don't want to see the white space in the card.
Yeah.
Like otherwise it will be like this. So if I keep the text empty, if I do not have this text, and you open the app, you'll still have this white space down there. So this is what I was trying to avoid, because when I open the app, I don't want to see this white space, because even if the text is empty, it's like an empty string. It's like one line of text. So since we don't want that, we can set the visibility of this card. But if we don't have any text, just hide the card. And let's wait for the emulator to open. Now here we want to use that API service. So bring that in API service. This is what we created. And then we'll call that get definition function and pass in the world. Not showing an error. What is it saying? Suspend function get definition should be called only from a coroutine or another suspend function. We'll mark this function as suspend. And now a suspend function can only be called from another suspend function or a coroutine. So we need to create a coroutine here. More specifically, we need a coroutine scope here. So how do we get a scope? We have this built-in scope for a view model, known as view model scope. And we can use this scope to launch a new coroutine. And we can put this function inside it. Now the error is gone. What is a view model scope? Like basically, what is a coroutine scope? So a coroutine scope, you can think of it as a bridge between the non-coroutine world and a coroutine world, because you can call this from a non-coroutine function. This function is not suspend. So here we are outside the coroutine world. So outside coroutine world. And here we are inside coroutine world. What does we mean by coroutine world? We can call suspend functions here. Suspend functions are those functions which might not return immediately. We call this function, and this function gives me a response. So let's store that response in a variable called response. Now we want to update our live data with the response that we have. Definition live data dot value is equals to this response is converted to a string format. So what is this response? It's a get, like it's a meaning. So this class is what we'll be getting as a response. Now let's see if the emulator has opened or not. It has opened. Let's run our app and see what do we get. Or do we get some error? Okay, there's one thing remaining. The app will surely crash. Now because we are using internet here, we need to open our manifest file and we need to add a special permission indicating the Android system that this app uses internet. So uses permission and add internet here. So add this line, use permission and internet, to indicate to the Android system that this app can be using internet. This is required, otherwise your app will crash. Close these pop-ups. Let's cancel this build. And let's run it again. Do we have any questions here? Keep asking questions if you have any. This is the first time you are seeing all this, so you must have some questions, I suppose. It is building. It will take some time. No questions right now. Okay, great.
Once you may try to go over all the process that is going behind, like starting with the activity, going through the view model and getting the response, and then showing it to the UI again.
Okay, sure. It has built. So we have our app here. Let's try searching for something. What do we search for? Let's say Android. On search button, it will search for it. Okay, it is not getting anything. Let's try something else. Search for the mouse here. Okay, there's some problem with it. Let's see, did we miss anything? I imported the wrong model. Okay. I should have named it something else. Not the meaning. I want a response model here. Because this is the model that we are getting the response in. We have to use this model. We'll be getting a list of response model. Let's run it again. Let's try something for Android. So we do get a data. So it is a response model. We have some meanings here. A noun, a definition saying in science fiction, a robot with human appearance, and then we have an example. So this looks good, but it is not in the format that we expected. So we need to format this a bit. And why we are getting this format at all? Because when we call dot to string on a data class, so data classes have their own toString function. We just list out all these functions. So it has a meanings, and each meaning has a part of speech and a definition. So part of speech and then definition. Definition is again an array of definition. So it has just printed out all the variables and their values straight away. You don't want to do it. You want to format it. So let's get a new function that will format this response.
That you can like go over the
Oh, okay, yes, I forgot. So what happened? We have a main activity. We start from on create, so it creates the activity. We inflate our binding here. So what is activity main binding? It's the same class, the XML class that we built. So this is our binding code, the XML code. This one. So this is the UI that we are presented with when the app opens. So if I just close it up and open it again, you will see the exact same UI. This card will be set to invisible. Let me open the app and open eDictionary. Okay, it didn't close the app. Go away. So if you open it, this is the empty screen that we see in the beginning. This is the layout that is inflated. And we set the content view, which just draws the layout in the screen. And then we have two things out here. The first one is, so this is the layout. So the card is invisible here. So there are two things that we're doing here. The first one is, whenever you click on this button, so we have a click listener set on it, we fetch the word that the user has typed in the search box. So binding.search text refers to this edit text inside this card. And from that text, we get the dot text to get the text out of it, and we convert that text to a string format so we can use it. Next, what we do is, if the word is not blank, so if you type an empty string here or just type spaces here, it will not work. It will just, this if will be evaluated to false and nothing will happen. But if user has typed something, we call this get definition function. So what does this get definition do? So inside this get definition, we launch a coroutine. Why do we launch a coroutine? Because we need to call this suspend function. Now, this is the syntax that we can use to launch a coroutine. We use a ViewModel scope. This is a coroutine scope that can be used to launch coroutines, and then launch just creates another coroutine, and we have a coroutine scope inside it. Inside this coroutine scope, we can call suspend functions. So now we are inside the coroutine world. We use the API that we had created. There's something to say, Arjun? Okay. We have this API service, which is a definition API. So inside this definition API, which is an interface, we have marked the functions that we need to call and the endpoints where we need to send a request to. This is a suspend function. We name it get definition. We pass a world to it, which is string, and this function will return a list of response model. And now, how have we built this response model? So we take a look at the JSON data. There's a lot of data here. We just filter out all the data that we require. Just ignore all the other attributes. So we see that it starts with a list. So we have a list of this model here. And then what does the JSON model contain? It contains world, phonetics, etc. and the origin. We do not want these data in our dictionary. If you want, you can just mention it here and you will get that as well with the response. And you can display it. For this app, we are not displaying it. What we're displaying is these meanings. What is this meanings? This is an array of another object. So we have meanings as an array of another object. We named it object as meaning. And what does meaning contain? It contains a part of speech, which is a string, and then some definitions. So we have the part of speech as a string, and then we have some definitions. Now, what is the definition? Like it's quite nested, so you need to create multiple classes. Some API response will not be that nested, so use like just one, and some will be even more nested, so you might have to create 5 to 6 data classes. But these are pretty small, so not a big deal here. Now, this is the definition, each definition. So what does the definition consist of? It consists of a string definition that we have here. It's a string, and then it might or might not contain an example. So sometimes there is an example, sometimes there isn't. So when there is no example, we use a default value of null. If you want, we can also use an empty string here. Like both will work, and you can then later check if this string is empty or not. But null makes more sense here because null means that the value doesn't exist. So if the example doesn't exist, we use the null value, and if it exists, we use that example string as the value that we need. We ignore these synonyms and antonyms. We don't want them. They're anyways empty here. And then this thing repeats. So the part of speech was here, and then this another element of the JSON array meanings. Where we have another part of speech verb, and if you have more, we'll have all these listed here. So this is how we made the model, and this is the model that it returns. So what's the endpoint? This is the endpoint. How do we know what the endpoint is? It will be given to you. Like you will search that API inside the documentation. They will tell you in which endpoint they return what response. This is the endpoint, and at last we need to send the world, but we don't want to send a static world. We want to use that world which we passed here. So we just give it something name, then call it whatever you want, XYZ, and again you can map it with XYZ. So these two need to be same, and it has nothing to do with this name. Keep it world. That's all that we need to inform Retrofit. Now what Retrofit will do, it will create an implementation of this definition API and write all the code that is required to send this network request. We don't have to do it by ourselves because Retrofit is doing that for us. The only thing we need to tell Retrofit is what is the base URL that we'll be using, https:/api.dictionary.api.dev, and what converter factory are we going to use. So we'll be using Moshi converter factory here. There are others available also, like if you go to the Retrofit documentation that I opened in the beginning, Retrofit, there are a lot of converter factory that you can use. So if you scroll a little bit down, these are all the converters that we have. So we have JSON converter, Jackson, Moshi, protobuf, wire, and all that. So you can use whatever you want. You could have used JSON, but we used Moshi here. You can use anyone. So then we tell you that we'll be using Moshi converter factory to convert this JSON response into a data class, a response model. We build it, and using that Retrofit object, we create an implementation of this definition API. So we mentioned that we want to create implementation of this interface, and Retrofit will do all the other work by itself. Now coming back to the view model. Now we use this API service. We call this function called getDefinition. Now the control will stop at this point. It will not move to this line until this function returns. So it will return after some time because the request goes and the response comes. The duration will be short, like from 1 second to like half second or maybe even fraction of a second. But then it will control will stop here because it's a suspend function. It's a Kotlin feature. And then when we get the result, we update our live data value with the string format of that result. And what we are doing with this live data is that we are observing the value of this live data activity. So whenever the value of this live data changes, like whenever we write something like this, we change this value, so this function will get triggered. This is the format of observer pattern. What are we doing inside this thing? What we need to do when the value changes is, first we need to adjust the visibility of this view model class, sorry, this definition card here. So if we have a empty string, we want to hide this card. If the string is non-empty, we want to show this card. Second thing we want to do is we want to update it with the text in the definition text. So whatever response we get, we want to update it in the UI. This is all that's happening. Like this is a whole cycle. Any doubts still here? Can you add that Android manifest? Like what do you want? Just should we paste it in the chat or show that again? And if anyone has any doubts, just you can put it in the chat box. Show that again, okay. So this is a manifest file. Like whenever you create an Android project, you will get this manifest file by default. So it defines all that information that the Android system needs to work with your app. So just to give you a walkthrough to this. So this is the application tag. Ignore this one. This is the icon that we use as an app icon. So IC launcher is the default icon that we get. So if you go to this, so whenever you create an empty app, this is the icon that you get. So it is defined here, the icon. The label is the app name. So whatever name you have given to your app, that will come as part of this label. This is another round icon. So some phones display app icons in a round format and some show in a kind of a square format with rounded corners. So it accepts two icons. This is a normal icon and this is a rounded icon. So in phones which this is not rounded right now, but this can be rounded off. It is using the same logo here. Supports right to left. We don't care for this. This is for that languages when you have like Arabic languages, so which are written from right to left. So does our app support it or not? Just give it a true. The theme that we are using, so this is the default theme that is made. Fine. Now here we will list all the activity that we're using. So all the activities in the Android application need. We only have one activity with name main activity. Exported means is this activity exported to the Android system. So if I will set it to false, our app will not open at all because the Android system will not be able to open this app. For it to open, it should have access to this main activity. It is also showing an error here. A launchable activity must be exported. So we have this launcher here. This is the activity that we want to launch when the user clicks on the app icon. So this is the launcher activity. So out of all the different activities that you have, you must have one launcher activity. Now this is the launcher activity and we need to export it so that the Android system is able to open the app when you click on it. This is all the information that we need here. And I added this one permission here, which is the user's permission. So this app uses this permission. The name of it is android.permission.internet. So our app is going to use internet permission because if it allow it, the Android will not provide internet access to our app and our app will not work. Does that clear a doubt? The Gradle scripts are for user use only. It has any function like you showed some dependencies. Okay, let me give a 2 to the Gradle file as well. So there are two files here. One is the project level, you see the project e-dictionary, and one is the module level. So module e-dictionary app. What is this module? So if you just minimize everything, this is one module that we have, and then we have Gradle scripts. This is where we are working till now. This is the project level one. The project level defines the basic dependencies, all the class paths that we need in our app. So these are the two repositories. So these repositories are the places from where it will fetch the dependency. So whatever we write here, these will be searched for in these repositories. So it will search in these two repositories. The one is the Google and another is the Maven Central. These two are popular repositories to host your APIs. So if you create your library, your own library, you will host it probably in the Maven Central. And then these are the basic Gradle dependencies. So this is the Gradle version. Gradle is the build system that we use in Android. There are others as well, but Gradle is the kind of the easiest one. This is the Gradle version that we'll be using. And then this is the Kotlin Gradle plugin. So the Kotlin version that we are going to use, the Kotlin plugin version. You need not touch it anything here. Now this is the app level file. So it starts the plugins. So what are the different plugins that we are going to use? So one is the Android plugin, and another is the Kotlin Android. The plugins mainly create some files, so like auto creation of files. These are basic ones that you need to make an Android app. Then we have the Android part here. It states the compile SDK. So there are two, three SDK. Like this is mostly the same as this one. Min SDK represents that our app will run on all devices version level 21 or above. So 21 stands for lollipop. So if like you might be familiar with the Android versions, they are all like in alphabetical order. Like L for lollipop, then we have marshmallow, then nougat, then Oreo, and then P for pie, and then the naming stopped, and then we have QR, and now S is coming. So this represents to S, and this is the L, the lollipop one. So if someone is using an Android version lower than lollipop, will not be able to install our app. This is the app name. This is the version code. You don't need to change it anywhere. This is required when you publish your app to some Play Store, like Play Store. So when you need to update your app, you need to update this version code. And this version name is when you like go to the settings of your app, you see this version name here. Ignore this one. You don't need these one. We are not working on release type here. The Java version that we'll be using, the Kotlin options, we'll be using view winding, so we need to enable it in build features. Then we have the dependencies. These are all the libraries that will be using your app. So it automatically provides some libraries by default. The bottom three are for testing. Ignore this. We have a core library which contains all the main files like your main, like this app comp activity, and all the basic files, the fragment ones, and all those they are present in that Gradle dependency. Some are in the core and most of them in the app compat. Sorry, this is the dependency which contains all the basic files. Now this is the material theming. So if you remember in the card that I used, so it was com.google.android material card. So we are using material theming here, and inside the theming also, like if you go to the resources folder and this themes one, so we're using material components here. So material theming is just another style guide that you can use. You don't want to play with this, obviously, normally. The constraint layout is the layout that we're using here. Skip all these defaults and just add the new ones that we want to use. So I added the two ones for the one for the retrofit and another for the Moshi converter, and then the two for ViewModel and the activity KTX. Whenever you want to use a new library, you need to write an implementation for that so that it is downloaded there. Like if you go to the project view, you can see these external libraries here. So these are all the libraries that you are using. If I search for retrofit here, you'll find it. This com.square.retrofit2, the converter Moshi. Then we have this retrofit. Like you can find all these, but you need not play with them right now. Just keep it as it is. Okay, now does that answer your question? You can write in the chat box if it answered or You need some more. Okay, got it. Great. So I guess we can move on right now. So our app is working. With this one problem, the format it is giving is not what we want. We don't want this ugly format. We need to format this whole string. Something like this. Now, one thing you need to notice is that it has some like bold things here. So this text is bold. And what we are using right now is a string. Like this is a string, a live data of a string. We cannot have bold characters in a string. That will not work. So we need to use some different like kind of what you can say data structure which can store formatted characters as well. So actually, if you look in the string class, it actually implements this char sequence interface. So char sequence is kind of a broader class which supports all the character types. So let's do one thing first. Let's specify that this the data type that we want here is a char sequence. It's like a string but with more features in it. Let's create a new function here. Make it private, fun, format response. It will take this response that we got, response model. Let's call it just response, and it will return a char. We can close it for now, and this will be like format response. Take this response. It's actually a list. Element of this list, right? Response dot first. So here we only like the first response. Most of the words do not have multiple elements in the list. Just ignore it. Now this is where we need to format it. Next few minutes will all be about formatting this string, like adding spaces, making it bold. Okay, now how do we make a text bold? So it's another thing that another task that we need to do. So let's get a function called bold. It accepts a string. Let's call it s. It returns a char sequence. Now to enable, like to add formatting to it, there's another class called spannable string that we can add different spans. For example, we want to make a part of the string clickable, or a part of the string should have a different color. So like we have one text, let's say it is hello world. We want this part to be in color blue, this should be in red, this thing should be clickable, this thing should be bold. So in a normal text view, what we do is if you specify this stuff in the text view. So for example, we have this text view, and if you write, what do we write here? Style bold. So if you write bold here, bold everything. Like here you can say, see, the whole text is bold. We don't want that. We want only parts of our text to bold. How do we do that? We create an object for span string. So well, spannable string. Get an object of this using this string. We need to make the entire string bold. So how do we do that? Spannable string dot set span. Now it has some parameters. The first one is what? Like what span do we want? So we want a style span with a typeface dot bold. We want a span makes things bold. Now what part of the string do we want to bold? We want to bold this entire string. It accepts two indices, the starting index and the ending index. So the starting index is 0 and the ending index is s dot length. The entire thing. The fourth part is to specify which index do we want to include and which one to exclude. So if you write spannable string, so we have four options: inclusive, exclusive, 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 inclusive, and inclusive, inclusive. So what do these mean? Do we want to include this index or not? And do we want to include this index or not? So do we want to start from 0 or after 0? And do we want to stop at this index or before this index? We want to use the 0 index, so we use inclusive here, and we do not want to use this index because this does not exist. Because if you have a string of length 5, it will have index to 4. So stop before 5. So exclude this last index. So this is the flag that we need to provide, and then just return this spannable string. Now we have a function which can make a string bold. Okay. Now we need to build a spannable string using these. So use build and string. Then we can add all the code to build that string. Let's see what do we need. First of all, we need a part of speech text which is in bold. So we need to append, like even before, we need to iterate on all these parts of speech. So we have multiple of these. These are called meaning in the object. So we need to iterate on all these. So response.meanings for each. Way to write this thing. So you can also write for meaning in response.meanings. Both are the same thing. You can use meaning here, but this is a more functional approach. You can say Kotlinish approach, and this is the kind of the procedural approach. So you can do whatever you like. I will go with thing, the for each function. We have a meaning, and we need to append in the string a bold string called parts of speech. We have this text here, and after that we need to append the actual part of speech. Okay, so let's now append the actual part of speech. So meaning dot part of speech. After that we need new lines. So we need a new line to get here, and then another new line to get here, to put the cursor here. How do we get a new line? So we have actually a new line character. This slash before we have two of them. The first one will put the cursor from here to here, and the next slash n will put here. We'll have an empty line in between. Okay, now we have this line. Next, we want to print out the definitions. Some have examples, some don't have. Let's iterate on the definitions. Meaning of definitions for each definition. Now we're iterating on all the definition. We first need to like append this string, the definition one. So let's append it, and in a bold format we want this. And okay, definition and a space. Next, we want to append the actual definition. So definition dot definition. This is this definition, if you remember. Now we might have an example in some cases. In some cases we might not. So we need to check for it. If this example is not null, so if we do not have an example, it will be null. If it is not null, we want to append it. So append. Let's start with this example, this bold text here. So in bold format, we write example, and then we append the actual example, which is meaning dot, not meaning dot, definition dot example. Now, after we have printed the definition example, we want to again leave a new line. So one slash n to bring it to the new line, this line, and another slash n to bring it here. So and two new lines here. And then once we have printed out all the definitions, we want two new lines here to indicate that one part of is over and another one is starting. So we can use this slash n, or if you use another function called append line, use whichever you like. This will append a new line at the end of this. This is all the form. This was just the formatting of response, or desired format. So we have formatted the response and set the live data, and let's see if it works or not. What is function of append? So append is a function in this scope. So spannable string builder. So if you have a string and you write like this, so s plus is equals to a, b, c. What we are doing is we're kind of concatenating, or you can say appending. So you have this string If you say s dot append, I'm not sure if it works for string or not. Let's see. Yes, this will probably not work. So we do not have append in strings. But in string builders, it's kind of a string builder, spannable string builder. We have this append thing here. So what it does is, in the string that we have generated so far, append this new string, or should I say a char sequence. It just concatenates the new thing with the previous one. Now let's search for our mouse. Let's see what response do we get. Okay, we got the response. So it's a noun and it looks good. Let's search something else. Now some words have a lot of, like, can be used for multiple parts of speech. One such word is use up. So up has a lot of meanings. Let's see what do we get. Okay, so it is an adverb, like he jumped up, and then another adverb, she turned the volume up at the keyboard. And because the scroll view now, that response is too big, we can also scroll it. So let's scroll it. So that was the adverb. Now we have a preposition. So up can also be used as a preposition. We also have some noun, verb, and adjective here, I guess. So all the different part of speech we have processed and displayed in the UI. Okay, there's one more case, the error handling part. So what if we have an error? Let me type some garbage data here, like A, B, C, D, E. So it does not exist. So what will happen right now is that the app will crash. Let's see. Okay, it crashed. Now why? So you might have seen in the response, this one. So type some random word. The response I get is like a title and a message and a resolution. But what we have asked for is, we have told it to return a list of response. So what is happening is that Moshi is trying to convert that response, the JSON response, into this format, and it is not able to do that. That's why our app is crashing. What we want to do is, we don't want our app to crash. Instead, we want to handle this error. So in the view model, when we call this get definition, and the way we handle it is using a try catch block. So what it means is that, like, this is the code that we have. Try to run it. If there is an exception, catch it. Catch any exception that you get. And if there's an exception, what we want is, you can do whatever you want. Like in this case, what I will do is, I will say that word not found. So if there's an exception, the request failed or the word doesn't exist, I will why not found. Let's see if it works or not. Okay, let's type in something. Let's say A, B, C, D, E. Try to run it. So there exception, we catch that exception, and then we print word not found. Another word, let's say what, swim, maybe. Again, propel the body through water. They swam ashore. Mashed potatoes. Like we have made an app that actually works. It goes to a network, asks for a, like, makes a request, waits for the response, and when we get the response, it displays in the UI in a formatted way. So this was all the formatting required. This was the function for converting a normal string into a bold string. And then we just update the value of this text. So any questions here? But the app has been, like, we are done with the app part. You can spend some time explaining more about the coroutines. So doesn't even have any question regarding this. Like how are these things working? Okay, I guess yeah, please add something long. Get the scroll option too. Um, means like I search for something? There is a long response. Like where should I add it? Can you yes? I don't like this one I'm talking about. If we get a long response, you'll be able to scroll. You can see a scroll bar here. So we are able to scroll its response. Is this what you were talking about? Yes, that's it. Okay. So scroll works because we have added a scroll view here. If we had not added this scroll view, our text would not have been scrollable. So a scroll view covering this space, entire space beneath that text. Here we can scroll this. We have not a lot of files here. Like these are just 4 files and this one UI file. We haven't done a lot of work here, but we have been able to make an app which looks good as well, and it works. Nice. Okay, so let me spend some time explaining a bit about the coroutines. So this is kind of a tricky part, somewhat complicated. I will try to explain it in as easy way as possible, but hope you will get it. If you have any doubts, like write it straight away. I'll be checking the chats. Why do we need coroutines? Let me first give you an example. Okay, how many of you have idea about threads? Like you must have heard about threads and multi-threading. Like you have like even a slight idea of what it means. Like what is a thread? What does it mean by multi-threading? Anyone? Any idea? Yes, no? So that I can get an idea how deep should I go. No. Okay. And
Use the Android documentation for that.
documentation. Let me find it out. I'm not sure if it starts on the basics. Okay, so what do they say is that coroutines are the recommended solution for asynchronous programming. So before going to, I wanted to touch a bit upon what is asynchronous programming. Okay, so there are 2 types of operations. One is a blocking operation, and second is a non-blocking operation. So, to give a small example, what is a blocking operation? So, you must have worked in different languages, and you've used user input. So, for example, in C++, you write something like C in A. Maybe in Java, you write something like scanner, C.next. In different, these are all the different options to take user input, like let's say input. So what do these functions do? So let me take a sample C program. You must be aware of it. So let's say I say println, no, not println, hello, and then I say C in S, and then I say println world. So what happens is, if you run this program, you will say hello printed, but this world will not be printed because the control the program is blocked on this line. It is waiting for a user input. You have a thread. You can think of environment. So it's an environment where you can run code. So multiple threads mean you have multiple such environments. In one environment, you can run only one instruction at a time. So this program runs in a single environment, a single thread. And what happens is that at this line, it is asking for a user input. The thread stops at that point. It starts waiting for the user input for it to complete, and then only when you type the input, then the control proceeds to the next line. But this is a blocking operation. Why? Because until you type text, nothing else is happening. Like the program is just stuck there and waiting for input. For small programs like these, we actually want that. But for any system which is like user facing, we do not want to write any blocking operation there. Why? Because Android provides you a single thread for the basic operations. Like whenever you want to draw to something, you give a text view a text, and then you ask for it to display it. Like when displaying is a task, so there's a thread that is working on it, drawing the text on screen, and you do not want to block the thread. A network request is another option, another way of blocking code, another example of blocking code. So what happens when you send a network request? The request goes and the program waits for the response. So until the response comes, it is stuck there. And we do not want our main thread to be responsible for that code, that networking code. Because if our main thread is responsible for the networking code, nothing else will work in our app. The main thread will be stuck with that point. And if you try to interact with the app, like use some options, click on some button, it will not work, and the app will just freeze. You might have sometimes seen apps freezing and just hanging. So this is one of the reasons why apps hang. So you definitely don't want to do that. So since we are using Retrofit, so Retrofit handles this part for us of taking the control to the background thread and then sending a request. And when the response comes, it again gives the response back in the same thread. So coroutines are a way to write that code in a better way. There are multiple ways of writing multi-threaded code. Coroutines is one of them. So what does the Android team have to say about it? Let's say. So coroutines are the recommended solution for a. There are two types of programming. One is synchronous and another is asynchronous. Synchronous means like one line is executed after the line. So this line, then this line, then this line, or this line, and here like this one, then this one, then this one. Asynchronous that they are running kind of a parallel environment. So they are running in parallel programming, in parallel. What are the advantage of coroutines? They are lightweight. You can run as many coroutines on a single thread with support for suspension. So coroutines are very lightweight, and they are not really threads, lightweight threads, and there are fewer memory leaks. So it leaks fewer memory. If you use other solutions, it in memory leaks, and if you have a lot of memory leaks, your app might even run out of memory, and the Android system will even crash it. So built-in cancellation support. So why do we need cancellation? So suppose this case, you send a request and response yet, and the user closes this app. When if the user closes this app, the request that you sent, that's of what we want is that that request should get cancelled. Whatever work we are doing, all that work should stop when it's no longer required. If the user close the app, stop this work. Because if you want, it might lead to memory leaks. In worst case, it might even lead to crashes. Your app might even might even crash if you have such keep on the work ongoing. So you need to cancel it, and Coroutines has a cancellation support. What using a ViewModel scope, what happens is when you close the app, let's say I press the back button, this ViewModel will get destroyed, and there's a function on ViewModel called onCleared. So this is the function that is called when the ViewModel is kind of in this function, it cancels this ViewModel scope. So this scope gets cancelled, and what happens? Scope, all the work that it has done, all the coroutines that it has launched, all those will get cancelled. So how does it cancel it? It throws a cancellation exception, and using the exception, all the children coroutines they get cancelled. This is how you get the cancellation. Cancellation is propagated automatically through the running coroutine hierarchy. If this that exception is propagated to every child, and it informs that child that you need to cancel your work because it's no longer required. Ignore this part, that jetpack integration. So you have extension functions using activity and ViewModel. So this jetpack integration is what helps us using this ViewModel scope. So this is part of that jetpack integration. We are getting a ViewModel scope inside this ViewModel. So you can add this coroutines dependency. We do not need it because this dependency is already provided by Retrofit. You can go through these examples, but this will be out of context for this point. You might not understand this part. Arjun, should we cover it? This thing like not belong to the current context. What do you say? Am I audible? Guys, can you someone put in the chat if I'm audible or not? Like, can someone write in the chat if yes, you are audible? Okay, Arjun is busy somewhere. I don't think this will be a little complicated for the sake of this discussion. I don't think I'm going through this right now. Let's not go through this. This is still our simple example. So, like, what if we are not using coroutines? Let me just show you what happens if we are not using coroutines. How do we write code? How do we used to write code without coroutines? Let's take some example for it. Let's see your friend, my friend, and you ask your friend to write an assignment. Dot do my assignment. Suppose it's a function, and definitely writing assignment some time, so it will not complete immediately. So earlier, what we used to do is we used to add listeners for this. So, like for example, this thing. You not understand exactly what it is. I'm just trying to demonstrate the pattern that we used earlier without coroutines. The code was something like this: my friend will do my assignment on completion. So when the assignment is completed, so you have the assignment. Now what do we want to do with this? Let's say we want to upload it to some drive link. So I ask some other friend. But this will be actually be API calls. Like for example, this will be like API service dot get definition. So some API service dot some function. So let's say upload to drive. Now this will take time. So we need to add a listener for this as well. On completion. If someone has used work with Android, maybe like Firebase, you might be familiar with these functions. Like every API for these functions. Let's say we have the upload link, and what we want to circulate this link. So, friend, and I asked him to circulate this link. Now it will take some time as well, and then when everything is done, everyone has the assignments. It's great. Party time. This is the code that we used to write. Now this doesn't look that bad, but hold on. This is a request. Like we ask. Now consider this API example. We ask some API to make some request, and those requests can fail. Whenever we have a task that can either succeed or fail, so we need to handle failures as well. So all those APIs that expose this on completion function, they also have something to handle failure. What if this do my assignment call fails? So the code might be something like this: on failure, and something, whatever, like a request failed, the world looks gloomy, it's bad. Okay, now say this thing succeeded, but now this failed. So again, like similar thing. So if it's not, we have not been able to upload it to the drive, again a bad thing. Don't want that. Formatting, it looks good. It should be like this. And again for this request as well. Earlier the code was looking pretty good, but now like the success case is small, and the most of the part is code is spent on failures. we do not want to write such code. If you like study about it, these are called callbacks. This is a callback. So this work is done, and when it completes, we get a callback. And that is the pattern that we can avoid with coroutines. So we can write code that runs in parallel, but we can write it as a sequential code. We can do parallel programming, but it will look like a sequential programming. If you read this line, it says val response API.get definition. So get definition is a suspending function. It does not return immediately, but it looks so natural because we have the response and then we can just set it here. This is because of the coroutines. If you are not using coroutines, you have to like fall back to this pattern. Because coroutine, like Retrofit also supports this pattern. It has calls like retrofit call.enqueue, and then these two callbacks for completion failure. So coroutines is really powerful. You can study more about it. Like if you go to the Android, you must have visited this once. Okay, and then the unit 4 to the internet. Just open this one. And then you have a activity on coroutines, and then this is the retrofit part. If you explore this coroutines part, there are a lot of code labs here. Where am I? This is the video, and this is the code lab. You can go through this code lab and learn more about coroutines. This is pretty big, so I didn't want to cover it. This talks about threads, like single path execution, task 1, then task 2, and task 3. And then we have concurrent execution. So all these tasks are running simultaneously. So like till this point, we have 2 tasks running together. And from this point we have 3 tasks running together. If we run tasks in parallel, we will reduce time. The things get faster. And this is the way we used to do it using threads, like without using coroutines. You can give it a read. I'm not going to cover the entire part. Here they have created 3 threads and use them through case conditions that we get and some unpredictable with threads. The threads are bad and hard to handle. So you can go through all this. They are suggested to go through all this. Like, okay, it ended pretty soon. They haven't covered a lot of stuff here. Just the basic stuff, how to launch a coroutine. So you can go through relatively good practice for you. But for now, I think this much knowledge should be enough for building this particular app because we are using coroutines at just 2 places: this ViewModel scope, and then we have added this suspend function. That's all that we have done for leveraging the coroutines power.
Arpit, you can actually discuss about the probable application that we'll be creating, like submitting from our institute.
Okay, just a second. Can we add like a voice of how the word is pronounced? And if suppose history is to be stored, like we use linked list or stack. Okay, you want the voice. So this response does give you a voice file. What you can do is, just to give you an idea, like you have a phonetics and an audio here. Create a new data class for storing this. Won't be running this because checking audio is not big. And then you can ask for this variable as well. What's the name? Phonetics, and it's a list. Okay, list of. Okay. So if you add these parts, the response that you will get will also include this audio file. What you can do is you can grab that audio file and maybe just add a play button here, and then when you click on this play button, you can stream that audio from it. So streaming audio is beyond the scope of current class. You can do, you can search Google for that, like how to open a stream. There will be an audio stream and you will connect it to the speaker. So there will be some function to play that. We won't be covering that here. And then what if history is to be stored? will be used linked list or stack. Storing data, there are two types. There are two ways you can do that. First is you can store it like for this particular app session only. So like user opened the app, typed some words, and then you can show history. Second one is you can persist it. Like what were the words the user searched for when he last opened the app. So if you only want to keep the data till the app is alive, maybe you can create a here, private val history, and then you can create a mutable list of string string. And then whenever the get definition function is called, you add history, you add that word to your history list. So there will be one word followed by another. So 0, 1, 2, 3 indices. And you can display it in the UI if you want to. Like just make it as a lab data and then just observe that lab data here and show that text. Yeah, I can do it right now. Like how much time will it take? Let's see. Okay, let's remove the definition part here and let's display the history text. Let's see if we are able to do it quick. I don't want to spend a lot of time here. History lab, and it will be a new table live data. We'll have an empty list in the beginning. An empty list will be a string list. What do we want to do? Live data dot value, get the previous value, and add our word to it. Fine. And let's use the same text view. So instead of observing this live data, let's observe the history live data. It is actually a string list, so let's convert that list to a string. Maybe we can use different lines here. So let's try running it. History was easy. Now, second way where you can store history is you can persist in the disk. That when the user opens the app next time, I want to fetch the history that we had saved in the disk. So we need to save it in hard storage. How to do that? That will be a topic for the next session. How can you create your own database and store data in it? It will persist the app like live. So even if your app is destroyed, it's closed, will still be able to store data there. Let's see now if we get history or not. So let's search for moon. Okay, not that, this moon. We have moon here. And let's search for apple. We have apple. Anything. Orange. We have orange. You can keep this history. Let's just create a new live data. Update its value whenever this function is called. Let me undo. Like, you can see it for now. Does that answer your question, Gaurav? Did you understand this part? Just create a new live data. Now this live data is of a string, like it's a list. So whenever you have a new data, we take its value and we add this new word in the original list. And then we are list in our activity. Now what this does, it is a string. We want to join all the elements of this string using like with /n. Like all the elements are separated by a new line. So does that make sense to you, Gaurav? Okay, great. Let me undo it for now. And for storing the persisting the data, we might be having a next session covering how can you create your own database and store data there. Okay, let's undo it. Okay, we are back to the point. Great. Any other doubt? Anyone? I guess we are close to the end. So, like, if you have doubts regarding Android, like when not related to this app, we can take some small doubts here. We can't explain the entire concepts, but we can take small doubts. If you have, you can ask. Okay, Arjun, should we end? I think we can.
Sure. Thanks, guys.